So in this lesson, we're not going to be learning new factoring methods, but we are going to see one way that we can use factoring to solve equations. And this is going to kind of lead us into our second part of the unit, which is about solving quadratic equations. So first off, it says, one of the most important equation solving techniques from a fact stems from a fact about the number 0 that is not true of any other number. So if I have a product of multiple factors, so if I have a bunch of numbers multiplied together in a row, we'll just use variables for them, like A times B times C equal to 0, that means that one of these three, at least one of these three, has to equal 0. So either A equals 0, B equals 0, or C equals 0, and possibly more than one of them equals 0. And if you think about that, if you try to think of three numbers that multiply to 0, you'll realize that one of them has to be 0. So using this fact, if we have binomial factors, such as we have in exercise 1, so here I have my two factors are x plus 7 and x minus 3. The product of those two equals 0. That means that either x plus 7 has to equal 0 or x minus 3 has to equal 0. So to solve this equation, now we've split up this equation that has factors in it into two linear equations that can be solved very simply. So this subtracting 7 on both sides and adding 3 on both sides, we are kind of already talked about that in the first unit. That's not something you need to show, but I do want to show how I got those answers. So those answers can be left like that, or since they are two answers for x, you could write them in roster notation like this. Either way is fine. So looking at the next one, same idea. Now my two binomial factors multiplied together that equal 0 are 2x minus 5 and x minus 4. So I'm going to show a little less work this time. I'm going to write 2x minus 5 equals 0 and x minus 4 equals 0. This one I'm just going to show, I know if I add 4 to both sides, I'm going to get an answer of 4. I'm going to erase a little bit here so I have a little more room for the second one. When we have two numbers to move, you can also do both numbers in your head, that's fine. But basically the process is we're adding the 5. So for the first one I am going to show it and dividing by 2. So x equals 5 halves from this one. So the next one, we now have three factors that are equal to 0. So 4 is the first factor, 3x plus 2 is the second factor, and 4x minus 3 is the last factor. So either the 4 equals 0, the 3x plus 2 equals 0, or the 4x minus 3 equals 0, or some combination of those. Now, my first equation doesn't make sense. 4 can't equal 0, so I'm going to cross that out. These other two can be solved. So this is the part you can do in your head. Minus 2 divided by 3 will give me negative 2 thirds. And plus 3 divided by 4 would give me 3/4. So either of these answers, the ones from part B or the ones from part C, we could write in notation like we had over here where we had the negative 7 and the 3, or you can leave them just as x equals. Now when I look at these factors, pairs of factors, we can tell from what we've done earlier in the unit, those came from quadratic equations or equations with an x squared in them if we were to multiply out those factors. Now, we don't want to because it's better to have them factored here, but a lot of times when we do these problems, we're going to start out with a simplified expression equal to 0 or a simplified expression equal to another simplified expression. We recognize that in this expression we have an x squared, and that tells me that I might want to factor if possible and then set each factor equal to 0. So we're kind of heading towards what we had in exercise 1. So in my first equation, I see that I have the difference of perfect squares. So this would factor into 4x plus 3, 4x minus 3 equals 0. If these two factors multiply to 0, then either one has to equal 0 or the other one has to equal 0. And then if I solve them, I'm going to get negative 3 over 4 here, minus 3 divided by 4, and positive 3 over 4 here. So I'm going to write them in that roster notation. So I have 3/4 and, negative 3/4 and 3/4. Hello, okay. as my final answers. So let's look at the next one, 4x squared minus 7x plus 3. So in our next problem, we have another quadratic, right, an equation with an x squared. So we're going to try to factor this one as well. Now this one, I don't have difference of perfect squares. I have a trinomial, and I noticed that a is greater than 1. So I'm not really going to spend a lot of time explaining the factoring methods because that would be something you'll need to go back to the last 4 lessons for. But on this one, we're trying to find numbers that multiply to 12 and add up to -7. We are going to split the middle after we do that rainbow. Those numbers that will work are -3x and -4x for splitting the middle. So now we'll group, take out the x, 4x minus 3, take out the -1, 4x minus 3, and then we will go to our 2 binomial factors. Now, 2 common mistakes. One is stopping here because, well, I've already done a lot of work, right? So it feels like maybe I should be done. The other problem is if you go back and factor, you might decide that you want to solve. But those problems we did for the first 4 lessons do not have equal signs in them. So do not do what I'm about to do now to finish this one on those problems. That's part of just recognizing structure. If it's not an equation, and also the problem just says factor, you don't want to solve it. So here, this is ask your teacher, but I'm okay with you skipping this as well. If I know both of them are equal to 0, you can go straight to, well, this one would give me a 3/4, and this one would give me a +1. Okay, so I don't really have room, so I'm not going to write it in the roster notation, but I could and for that problem. So my next one, same deal, quadratic, right? 15x squared minus 25x equals 0. This time I have a GCF of 5x. So I'm going to factor by GCF. Now something a little different that happens here, we'll notice that we have a monomial factor, 5x equals 0. Now unlike this situation where 4 equaled 0, 4 can't equal 0, but 5x, because there's a variable there, can. So in just a second after I write the other one, and this one I did choose to write out those factors even though I skipped it here just because I wanted to show the work. Here, to solve this, I would divide by 5. 0 divided by 5 is just 0. So if there's an x in that monomial, your answer is going to be 0. If it's just like a 5 equals 0, you cross it out. On the other one, I'm going to have plus 5 divided by 3, so 5/3. So those are my 2 answers to this equation, or that equation. Okay, so when I come down to D and E, you'll notice I don't have them set equal to 0. So in a lot of equations, like if it's a linear equation, we don't set it equal to 0. Like in the last unit, I just moved stuff around till x got by itself. But with quadratics, we can't do that because we have x's and x squareds, and there's no way to really kind of get it down to just one of those two. So we still need to set it equal to 0. So for in this case, I'm going to move over the 2x and the 10. So I add 2x, subtract 10, do the opposites, and move those over. So that's going to give me x squared plus 5x minus 24 equals 0. Now, this quadratic is a nice easy one, right? We have a equal to 1, so we're just finding numbers that add up to 5 and multiply to -24. Those numbers are +8 and -3. So if I solve this equation, if I set each factor equal to 0, I get a -8 and a +3. Looking at the next one, same thing. We have an x squared, actually 2 spots with x squared. Now on this one, it's maybe a little less obvious as to which way I'm going to move the terms. Right? I can choose which side to make the 0 and which side to kind of gather all the terms on. Basically, I want to keep my x squared positive to make the factoring step easier. So I'm going to move over the x squared, the 3x, and the -2. So here's all my opposites. That'll cancel everything on this side. Writing it on this side, this gives me 2x squared plus 9x minus 5 equals 0. Okay, so from here, right, trinomial, a greater than 1, no GCF. So we want numbers that add up to 9 and multiply to -10. So splitting the middle, those two numbers are positive 10 and negative 1. And then we're going to do our grouping. And that gives me x plus 5 times 2x minus 1 equals 0. So my values of x are negative 5 and positive 1/2. Now, if you have trouble factoring, like you really didn't do well with the factoring, this is going to be really hard, okay? And factoring comes up often throughout the year, so that's why they call factoring a gateway skill for algebra, specifically algebra 2, because it's that thing that we use in a lot of different situations. So if you don't have that skill, it does make other problems harder.